Welcome, everyone, to another episode of AI on AI, where we explore cutting-edge developments in artificial intelligence and their impact on technology and business. Today's topic, Conversational Recommender Systems, or CRSs, and how a new framework called STEP is shaking things up. Think about your favorite streaming service suggesting movies mid-conversation. Now imagine that powered by AI that truly gets you. To kick things off, Expert 1, can you explain what conversational recommender systems are and why they're such a hot topic right now?
Sure thing, CRSs are systems designed to recommend items, like movies or products, through natural back-and-forth dialogues. Unlike static recommendation systems, these focus on dynamic interactions. Imagine a chatbot that not only knows your preferences but adapts its suggestions based on real-time conversation. Businesses love this because it boosts user engagement and satisfaction.
Yeah, and the demand is skyrocketing because users expect personalized, natural interactions these days. But here's the catch. Traditional CRSs struggle with deeper semantics. They can't always connect nuanced user requests, like "I want a sci-fi movie that's philosophical," to the right recommendations. That's where innovations like STEP come in.
Right, STEP, short for Stepwise Curriculum Learning for Context-KnowledgeFusion, is a big leap forward. It uses pre-trained language models enhanced with knowledge graphs, combining dialogue context with structured data progressively. It's like teaching an AI to solve puzzles by starting with the edges before moving to the trickier middle pieces.
Fascinating. Let's dig into STEP. Expert 4, what makes it such a game changer compared to older methods?
Well, STEP solves a core pain point: semantic alignment. Traditional CRSs either treat dialogue and external knowledge, like knowledge graphs, as separate layers or fuse them in a pretty shallow way. STEP uses a three-stage curriculum learning process to progressively align these two worlds. Think of it as training for a triathlon: swim first, then bike, then run. Each stage builds on the last.
Exactly, it uses what's called the F-Former module to fuse dialogue context and knowledge graph embeddings. This module employs learnable queries, kind of like fishing lines, to pull in meaningful features from both dialogue and structured data, creating a unified representation. That's crucial for understanding complex multi-turn conversations.
And let's not forget its use of dynamic prompts. STEP injects fused knowledge directly into the language model's prompt space. It's like giving the AI a cheat sheet tailored to the conversation. This ensures the system generates both coherent dialogue and hyper-relevant recommendations.
Let's bring this down to earth with some examples. Expert 3, any real-world scenarios where STEP excels?
Sure, take movie recommendations. Say a user asks, "Can you recommend something like Blade Runner?" A typical CRS might return generic sci-fi films like The Matrix, but STEP digs deeper. It uses knowledge graphs to recognize that Blade Runner 2049 is a sequel and matches the same philosophical tone. The result, a recommendation that feels intuitive and spot-on.
Another great use case is e-commerce. Imagine a shopper saying, "I need running shoes for trail hiking." STEP doesn't just look at the word running and suggest road shoes. It fuses dialogue context with product data, understanding that trail hiking implies durability and grip. It's smarter decision-making in real time.
And don't forget customer support. CRSs powered by STEP can handle nuanced queries like, "I need help with my subscription, but also what's new in your catalog." It balances operational efficiency with personalized upselling.
Impressive, but no system is perfect, right? Expert 2, what are some challenges or criticisms of STEP?
Oh, absolutely. One criticism is its reliance on curriculum learning. While effective, it's computationally expensive. Training a system to learn in stages isn't cheap or quick, and if you're working with a smaller dataset, like niche industries, it might not generalize well.
Another challenge is maintaining diversity in recommendations. There's a risk of overfitting to user intent and narrowing the options too much. It's like always recommending chocolate ice cream when someone says dessert. STEP does better here by using auxiliary tasks to boost diversity, but it's not foolproof.
I'd add that integrating multimodal inputs, like voice, images, or even sentiment, is still an open challenge. STEP focuses on text-based dialogue and knowledge graphs, but the future will demand more. Imagine combining voice tone with historical purchase data for richer recommendations.
That's true, but Step's modular design is a strength here. It's built to adapt, so adding multimodal capabilities is more evolution than revolution.
Great points. Now let's tackle a contrarian view. Expert 4. What about the argument that open-source CRSs could outperform proprietary systems like Step with enough community input?
It's an interesting debate. Open-source tools have the advantage of collective innovation, but they often lack the cohesive architecture and optimization you see in proprietary systems. Step's curriculum learning, for instance, is hard to replicate without a centralized R&D team. That said, open source could catch up if it focuses on modular, reusable components.
I'd argue the opposite. With the rise of open-source knowledge graphs and pre-trained models, the gap is narrowing. It's like Linux versus proprietary OS. Open-source solutions might eventually dominate due to flexibility and cost efficiency.
Sure, but let's not forget regulatory hurdles. Proprietary systems often have better compliance frameworks for industries like healthcare or finance, where trust and security are non-negotiable.
Before we wrap up, let's look to the future. Where do you see CRSs and frameworks like Step heading in the next 5 years?
I see a big push toward multimodal systems combining voice, text, and visual inputs. Imagine asking, "What's a good sci-fi movie?" while showing the system your list of favorite directors. The AI could synthesize it all seamlessly.
Agreed, and I think we'll see more emphasis on explainability. Users want to know why a recommendation was made. Step could integrate more transparent reasoning like, "I recommended this because it's a sequel to your favorite movie."
Let's not overlook personalization at scale. With Step-like systems, businesses could deploy highly tailored CRSs across millions of users without sacrificing quality. It's the holy grail of AI-driven commerce.
I'll add one last prediction. CRSs will become agents, not just assistants. They'll proactively suggest things based on your mood, schedule, or even health data, blurring the line between utility and companionship.
Incredible insights, everyone. Step clearly represents a big step forward, pun intended, in conversational AI. Thanks to all our experts for an engaging discussion. Listeners, what do you think? Could Step redefine how we interact with recommendation systems? Let us know and see you next time on AI on AI. Outro music fades in.
Today, we explore STEF, a new approach to conversational recommendation systems. The focus is on using advanced methods to improve how these systems match user preferences with high-quality recommendations. STEP addresses a common challenge, aligning dialogue context with external knowledge from sources like knowledge graphs. Knowledge graphs are structured databases that store information about items and their relationships. Traditional methods often struggle to connect dialogue context with knowledge graphs effectively. STET introduces a model that uses pre-trained language models and integrates them with a curriculum learning framework. Curriculum learning means training the model step by step, starting with simple tasks and progressing to harder ones. At the core of STEP is FFormer, a module that aligns dialogue context with knowledge graph entities in 3 stages. This staged approach enables fine-grained semantic understanding, improving recommendations. STE also uses lightweight prompts to guide the system's behavior during both dialogue generation and item recommendation. For example, a conversation prefix focuses on understanding user intent, while a recommendation prefix improves item ranking. In experiments, STEP outperformed other methods in both recommendation accuracy and dialogue quality. For instance, it achieved higher recall scores, meaning it retrieved more relevant recommendations. STE also generated more diverse and contextually relevant dialogue responses than competing systems. Challenges remain, such as optimizing the model for different types of conversations and datasets. Future developments could include incorporating multimodal data like images and videos to further enhance performance. This research highlights how careful integration of context and knowledge can transform conversational recommendation systems.